Okay, let's go. Progress test. Which distance is the longest? So this is testing your knowledge of prefixes. Okay, so if you've got 10 to the minus 18, okay, and it's giga, so that's 10 to the 9. All right, and then the way that you do that is you just add the indices, so that gets you 10 to the minus 9. With this one, you got 10 to the minus 13. Okay, and then kilometers is 10 to the 3. Okay, so that gets you 10 to the minus 10. And then this is 10 to the minus 2 times by micro. Micro is 10 to the minus 6. So that gets you 10 to the minus 8. And then 10 to the minus 1. And femto is 10 to the minus 15. So that gets you 10 to the minus 16. Okay, it's looking for the longest distance, which is 10 to the minus 8. So the correct answer is C. Oop, got to go do registration in a minute. Asteroid falling towards the planet. 10 minutes later, that's its speed. What's the average gravitational field strength? Okay, so what we're trying to do here is we're going to take these two speeds, all right, and okay, so if you've got no idea how to approach a question, right, just write down what the question tells you, right? Okay, so the initial speed here is 20 kilometers per second, and as always, we need to convert that into SI units, right? So that's 20 times 10 to the 3 meters per second, right? And then the later velocity is V, so that's the final velocity. And then we also know the time. And of course we need to convert that into seconds as well, don't we, right? So that's going to be 600 seconds like that. All right. And then it's asking us for gravitational field strength, all right? And you notice that the units are newtons per kilogram, okay? Now, you know that sigma F equals ma, okay? And in this instance here, okay, the only force that's acting on that asteroid is the weight. Okay, which is W, and that's equal, of course, to mg, right? So with some pretty straightforward maths there, you can see that the acceleration is equal to the gravitational field strength, okay? So that means that if we work out the acceleration, we've worked out the gravitational field strength, right? And hopefully now you can see that we know a formula that links all of these things, right? So we're just doing A equals V minus U over T. Okay, which is equal to 20.6 minus 20, all times by 10 to the minus 3, okay, divided by 600. So if you work it through, you've got 600 on the top, 600 on the bottom, okay, which is going to get you answer C. So a runner accelerates from rest and reaches a constant speed in time t. What's the variation of displacement with time? So when you look into a displacement time graph, you know, what is it about the displacement time graph that is going to tell you the velocity, right? Okay. Because we know that after constant time t, it's got a constant velocity. After time t, it's got a constant speed. Right. Well, if you look at the gradient of this one, you can see here it does have a constant speed, but the constant speed is 0, right? So straight away we can eliminate A and C from our thinking, right? Okay, now let's have a look at this one. Okay, this one starts off with a high gradient, then it goes to a medium gradient, and it goes to a lower gradient. So with this one, the velocity is high at the beginning. Okay, so the run is actually decelerating, because we're going from a very high V to a medium V to a low V. All right, so this run is decelerating, so that can't be that one. So the runner that's accelerating starts at 0 velocity, Okay, gets medium velocity, okay, and then high velocity at the end, and it stays constant after time t. Okay, so answer must be D. Car's got initial speed, decelerates, blah, blah, blah. What's the distance traveled by the car? Okay, so again, we're going to use our trick. We're just going to write down what the question tells us, right? So the question is asking us for displacement. Okay, it's giving us an initial speed of 16 meters per second. Okay, and it also tells us the final speed, right? Because it tells us that it stops. And it's also given us the acceleration. Now, because it's a deceleration, okay, we need to put in the minus sign. All right, so we've got everything that we need, right? No mention of time, so there's only one formula that links all of these three things, all of these four things together, and it's v squared equals u squared plus 2as. Substitute in 0 equals 16 squared plus 2 times by a times by minus 4. All right, so if you've got 16 squared on one side, and you've got, yeah, so you take that over to this side, so that's going to be 8a. All right, 16 squared divided by 8, that's going to get you, oh, sorry, I made a mistake, haven't I? Sorry, I should say S, not A. Oh dear, morning, that should be S, not A, my bad. Okay, so S is 32 meters. All right, so answer C again. Getting a lot of C's. All right, but don't play those mind games with yourself. Okay, you can have an entire run of C's. All right, so we've got a constant velocity past Sally, who's at rest. At this instant, Sally begins to chase Jim with a constant acceleration A. Okay, which expression gives the time Sally will catch Jim. So the okay, so here's Sally. Jim goes past like that, and then Sally starts off, and at some future point, they're going to reach. They're going to catch up with each other. So hopefully we can agree that, at that point, then the displacement of Sally, okay, so I'm going to call that S subscript S for the displacement of Sally, is going to be equal to the displacement of Jim. All right. So we need an expression for the displacement for Jim. Now he's traveling with a constant velocity, v, all right, and so we can use S equals v times t, right? And then we need an expression for Sally, okay, and this is the right expression for us, okay? And I've chosen this expression because it links the variables that we've got, right? It's got v's in it, it's got a's in it, it's got t's in it, right? Okay, we're after an expression for time, right? Now, because Sally starts at rest, we can get rid of the ut because your initial velocity is 0, so that term just disappears, right? So now you've got two expressions, and we can put them equal to each other because we said that when Jim's displacement is the same as Sally's displacement, then they're gonna catch each other, right? Okay, so then we've got a half AT squared on this side. All right, and then we just rearrange carefully. One of the t's will cancel like that, so you get 2v over this side divided by a. All right, and then that gives you t. It's another c, right? Okay, I'm gonna break the video here to make it easier for you to scrub through.